next we have a science question. Something that I've been wondering for a long time is why does liquid form a sphere in outer space?
Yeah, that's a great question. I think that maybe I would argue that not every liquid forms a sphere in outer space. The liquid that we'd be thinking of would definitely be water. Water 100% does form a sphere, or at least spherical-like, blob-like objects in space. And the reason for that is that water, and other liquids as well, but water in particular, the molecules of water are polar. And so water exhibits a property called cohesion, where water molecules are able to stick to each other. And it's that sticking together that water molecules are able to do that means that if you shoot off a little bit of water in outer space, the water molecules that make up that little piece of water, that blob of water, will hold themselves together. If we could jump to my screen really quick, I was just going to show a few pictures to sort of illustrate this point. So if you've ever filled a glass of water too full, you've probably experienced that you can kind of fill a glass of water above the rim and it won't spill over to a point, obviously. But this is an example. Hopefully you can see there's water rising above the rim of the glass here. And water is able to do this because it has cohesion, because the water molecules up on top there are essentially magnetically attracted to the water molecules below in the cup. And gravity, of course, is holding the rest of the water down in the cup. And so we get this little curved, convex surface of the water. So if we look at a water molecule up close, water molecules, most of us probably know that the formula for water is H2O. So what that means is that you have two hydrogen molecules connected to an oxygen molecule. In our diagram here, I can blow it up a little bit. The red balls represent oxygen and the white balls represent hydrogen. And you can see that water molecules have sort of it's often said like a Mickey Mouse head shape. This is the reason for their polarity. So the hydrogen atoms tend toward one side of the oxygen atom, and they hold more of the positive charge on that side, and so you end up with a positive end by the hydrogens and a negative end by the oxygen, and this is what makes water polar. This is why we say water is polar. It's essentially like a little magnet, and you can see here in this diagram we have the negative end of one oxygen attracted to the positive end of a hydrogen here, and that's continued throughout the diagram. And these bonds between water molecules are referred to as hydrogen bonds. They're not as strong as the bonds that hold, say, the hydrogen and oxygen to each other, but they're strong enough to do cohesion, which again is that property that we looked at. Just briefly, I guess I wanted to show you what it actually looks like in outer space. There's some really great YouTube videos that are put out by the space station, the International Space Station. This is an astronaut whose name I should know, but I'm blanking on right now. But he was up in the International Space Station, and he did a demo on what it looks like to wring water out of a sponge. So I'm just going to show a few seconds of this so you can see what that's like. So you've got, I don't know if there's sound here. We don't really need the sound. I'm not sure if that's coming through on your end, so I'm just going to mute it. But okay, so you can see, I'm just going to pause it there. You can see as he squeezes the sponge, right? Or the rag, I guess. He's squeezing water out of the rag. And that's making it so that the rag cannot hold as much water. But you'll notice that the water, on Earth, water would just wring right out of that rag and fall to the ground thanks to gravity. But in space, there is no gravity. And so the water has nowhere to go. If it didn't have the property of cohesion, it would just sort of float off in all directions. But it does have the property of cohesion, and so you can see that it holds together. And you can even see, maybe I can pause it as one floats away, but you can see that, oh, hold on, this is maybe not perfect, but as little pieces of water break off, they tend to break off into little spherical pieces. In any case, there's lots of videos that reference this, and you can check those out. Strongly recommend it. I will just mention, if you modified water by adding something like soap to it, you would break down water's ability to have that cohesive property. It would be more slippery, and water molecules would not be able to come in contact with each other as often to cohere to each other. So I would say not all liquids do form spheres in space, but any polar liquid would. So.
Got to clarify there.
Got to clarify, that's good. I think it's worth going into that stuff sometimes, right?
Just in case you were thinking of soapy water in space versus.
Well, I mean, we're saying liquid. If we're saying liquid, we're probably talking about water.
Right.
Like,
Right.
in
And that's
this
probably the
instance.
experience they've seen, like maybe on that YouTube video.
Yeah,
like
maybe
that.
maybe it was
Right.
something like that. Absolutely.